You know, obviously what we've been talking about here today is water. Why is water so important? We're looking for water. I want to bring you back to the Earth for a minute. Now, think about the fact the Earth formed about 4.6 billion years ago. By about 3 billion years ago, life evolved here on Earth in the oceans. And for billions of years, it remained in the oceans. So that's certainly one of the things that really drives us to look for these watery worlds, either in our own solar system or beyond our solar system. But you know, it's even more than it's just the experience of what we understand here from the Earth. It's the fact that the water molecule has these really unique properties, we think. It's a solvent. It moves things around. It has really unique properties that we think are really critical to the formation of life, not just here on Earth, but on other bodies in the solar system. Now, when you look at the bodies that we've been talking about here, that Jim Green and Jeff and Paul Hertz were talking about, that you see in this graphic, you know, Mars there in the top center, so critical, we think, to this search for life, because of the fact that water was stable, as Jim was saying, for possibly 1 billion years on the surface. So again, that goes back to what we know from our experience here on Earth. We think that long period of time is necessary for life to maybe get more complex. So when we talk about trying to find life on Mars, or maybe life on Europa, or on other moons of the solar system, like Enceladus that was at the bottom of the graphic that I showed a minute ago, we're not talking about little green men. We're more talking about little microbes. So this is going to be life that's going to be a little bit hard to find in our own solar system. And so when we think about that, we start thinking, how are we going to find it? Let's think about Mars. We've been sending these spacecraft. They have very sophisticated instruments. So what do we look for? We look for the building blocks of life. We look for organic molecules that might tell us that some process is going on. We look for something scientists call disequilibria. We look for things out of balance. Is there something that seems to be consuming something and giving something else off? So those are the things we look for scientifically. But ultimately, I'm a field geologist. I go out and break open rocks and look for fossils. Those are hard to find. So I have a bias that it's eventually going to take humans on the surface of Mars, field geologists, astrobiologists, chemists, actually out there looking for that good evidence of life that we can bring back to Earth for all the scientists to argue about and say, is this life, is it not? How do those cells compare to cells here on Earth? Do these microbes that formed on another planet, do they have RNA or DNA like life has here on Earth? These are the questions that ultimately I think it's going to take our astrobiologists on the surface of Mars to answer. So that's why NASA is so focused on our journey to Mars. And what are we doing to accomplish that? Well, for one thing, as John and Jim Green were talking about, we have a healthy program of studying the surface of Mars right now with spacecraft like MAVEN, with our Curiosity rover. In 2020, we're going to send a new rover to Mars that's going to move us even further forward towards understanding Mars's habitability and performing some initial experiments to get us ready to send humans to Mars. We're working every day up on the International Space Station with our astronauts to understand the long-term effects of spaceflight on human health so we can get astronauts to Mars safely and return them back here to Earth safely. And that's what the one-year increment with Scott Kelly and Mikhail Kornienko is all about. And the twin study that we just started conducting a few weeks ago with the successful launch up to the International Space Station. It's why we're doing commercial crew and commercial cargo. It's why we're developing the Space Launch System, our new rocket that will move humans out beyond low Earth orbit, and the Orion capsule, which we just tested successfully in December. So we have a whole program to move us forward on this journey to Mars, because again, if we come back to the scientific question, are we alone? Getting astronauts to the surface of Mars to help answer that question. Understanding the sun and its behavior and its effects on life here on Earth, but also helping us use that information to understand the potential for life on worlds around other planets. Using our great telescopes, like Hubble, and in the future, the James Webb Space Telescope, to start using the information we're gaining from understanding life here in our own solar system to understand beyond our solar system. Thank you.